AB Calculus Note Card 20 Acceleration. This video lesson is the 20th in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District. Acceleration is the instantaneous rate of change of velocity. It tells how quickly the body speeds up or slows down, how fast velocity is changing with respect to time. And here we have a list of 5 different possible notations. We have s double prime of t, d squared s over dt squared, v prime of t, dv over dt, and finally a of t. Positive acceleration is pushing a person or object, while negative acceleration is pulling an object. A particle speed is increasing when the signs of acceleration and velocity are either both positive or both negative. A particle speed is decreasing when the signs of acceleration and velocity are opposite of each other, one positive and one negative. Now we're going to go into an application in this problem. An object for t is greater than or equal to 0 is moving along the x-axis, so its position s of t measured in meters is given by s of t equals t cubed minus 9t squared plus 24t, where t is measured in seconds. During what intervals of time is the object moving to the right justified? Well, to find those intervals when the object is moving to the right, we need to find where or when this object is at rest. And to do that, we're going to find v of t, or velocity, which is equal to s prime of t, or the first derivative of this function here. And that's going to be equal to 3t squared minus 18t plus 24. And to find the critical numbers when that particle or object is at rest, we will set this v of t equal to 0, and we're going to start to solve by factoring a common factor of 3 out of each of these 3 terms. So we have 3 times quantity t squared minus 6t plus 8. And if we divide by 3, we can see that we have left 0 is equal to t squared minus 6t plus 8. And factoring this quadratic trinomial into 2 binomials, we have t here, and we're going to have a minus minus, and then that's going to be, I believe, a 2 and a 4. And so we have left our critical numbers are going to be t equals 2 and also t equals 4. So now we can do an analysis to see during which intervals the particle is moving or object is moving. So I'm going to create a number line here, and on that number line we're going to put our critical numbers 2 and 4, and we know we're starting at 0 because that's where the function is defined, and we're going up toward infinity. And on the top we're going to put v of t, which of course is s prime of t, and below we're going to just put s of t. And so just looking at this function here, if we take a number to the left of 2 or 0, we're going to have a negative times a negative. So we're going to have positive, which means the value of the function is going up, and that would be equivalent to moving to the right. And then between 2 and 4, we're going to have a negative times a positive, so the particle will be moving to the left in that interval. And then finally, greater than 4, we will be again positive or moving to the right. So we will say object moves to the right, and I'll just put right, on, meaning on the interval of 0 to 2, and also on the interval from 4 to less than or equal to infinity. And now the justification, because v prime of t, or I'm going to say v of t, because v of t, which is equal to s prime of t, is greater than 0. B, find the velocity of the object when the acceleration is 0. Indicate units of measure. And for that, we're going to use our notation shown in the prior card. A of t, which is what we're looking for, is equal to v prime of t. And that is also equal to s double prime of t. Okay, so 3 notations right there. And that's going to be the second derivative of the original function, or first derivative of the velocity. So that's going to be 6t minus 18. And to find when the acceleration is 0, we can just replace s double prime of t with 0. So we say 0 equals 6t minus 18. And then 0 is therefore equal to factoring 6 out of each term, 6 times quantity t minus 3. So our critical number is going to be, we would say, acceleration equals 0 at t equals 3 seconds. So we say find the velocity of the object when the acceleration is 0. So we're going to have to plug in 3. So using this function up here, v of 3 is equal to 3 times 3 squared minus 18 times 3 plus 24. And so we're going to get 3 times 3 squared. That's going to be 27 minus 18 times 3, which should be, I think, 54, plus 24. So v of 3 is equal to that. So we have, that's going to be plus 51 minus 54. So v of 3 is going to be equal to negative 3. And the units are going to be in meters per second. Okay, and then I hope that makes sense, because we can see that between 2 and 4, the velocity would be negative. So corroborative evidence. Next, C, is the speed of the object increasing or decreasing at t equals 2.3 seconds? Well, to do that, I'm going to take our A of t equals 6t minus 18. Okay, and we have v of t, well, we already have this up here, equals 3t squared minus 18t plus 24. So to find at 2.3 seconds, acceleration at t equals 2.3, we just plug in 2.3, we get 6 times 2.3 minus 18. And that's going to be equal to 6 times 2.3 is going to be 13.8, I believe. It will be minus 18, so it's going to equal to negative 4.2. Okay. meters per second squared. And then over here, V of t at t equals 2.3 seconds, we can go back to our number line analysis and we can say, okay, well, we don't know exactly what it is without plugging in, but we can say at t equals 2.3 seconds, V of t is less than 0. So we say increasing or decreasing. We say increasing, and as our justification, because V of t and A of t are both negative, or have the same sign. We can write that. Okay, D, find the average acceleration of the object for the time period from 1 to 3 seconds, indicate units of measure. Well, average velocity, or excuse me, average acceleration is going to be the average rate of change of velocity. And so what we're going to do is find, we consider these A and B like we've done in the past. We had average rate of change equals f of B minus f of A over B minus A. So we're going to find the average rate of change of velocity. So we're going to find first V of 3, and using velocity equation, we're going to have 3 times 3 squared minus 18 times 3 plus 24. And we already worked this out over here earlier, right? Negative 3 meters per second. Now we're going to find V of 1, which equals 3 times 1 squared minus 18 times 1 plus 24. And that's going to be 3 minus 18 plus 24. That's going to be negative 15 plus 24 equals 9 meters per second. So what we're going to have here is average acceleration is going to be equal to negative 3 minus 9 meters per second over 3 minus 1. So I'm going to get negative 12 over 2, which equals negative 6 meters per second squared. And that's it. I hope this helps. Good luck, and thanks for viewing.